Hello guys, this video will cover ACT35 science section. So when you think about science section, the first thing you have to have in your mind is we don't read the passage itself. Since we don't have that much time, we just go directly to the question, and then whatever question is asking you to do, and we just follow. And let's assume that you don't know, like after you're reading the question and still you don't know what to do, then you have to go up to the passage and try to read. But then this time it's not like one by one you read, speed reading to find the keyword. Okay. Let's look at the questions and then I'll explain more about this. So going to the question number 1. It says, according to the figure, the estimate number of 1 to 3-year-old cod present in 1980. So if you look at the figure 1, 1980 is here, and then we have to look at the y-axis. So this one is snow crab, and this one is cod. So right side is cod, so we have to look at the right side. And also 1 to 3-year-old cod is this empty square box. So then this one is the one that we look for, but then we still read the right side of this one because that's the cod. So because of that, the answer is D. Again, even though I didn't read anything, but still I can understand, I can do the question. So we can save some time from there too. And then number 2, according to the figure, when the estimate number of 1 to 3-year-old cod was greatest and the number of metric tons of snow crab cod was closest, which one? So we have to find something that when you can find the greatest is this one. And then snow crab is basically this bar graph. So then the snow crab is around this part, so maybe about 200, so that's why it's F. Number 3, in the relationship between cod and snow crab described in the passage are the cod the predators, or are they the prey? So in this case, if you look at the number of cod is going up when the snow crab is down, and then also the other way around, the later part as well. So which means obviously cod is eating snow crab, that's why snow crab is not as much. And also the later years, cod is not able to eat snow crab because they don't have enough. Then number of snow crab is getting greater. That's why you see that is predators, because cod is eating the snow crab. Number 4, consider the statement when the total estimated number of cod include those two was relatively high, the mass of snow crab caught was relatively low. So which means this question is similar to number 3 because those are predators, right? And then are the data in the figure for 1984 through 1986 and for 1992 through 1994 consistent with this? So 1994, like here, this one. So the cod is a lot and the snow crab is lowest. And then the second part, it says 1992 to 1994. So this one, snow crab is the most and then cod is the lowest. So it makes sense because it's the opposite. Because of that, it has to be yes. And then because they're like an opposite amount of number of whatever cod and snow crab is opposite. That's why. So it's F. Number 5, based on the figure, mass of snow crab caught was closest 500,000 kilogram in which following year? So snow crab, it says snow crab, so we have to look at the left side. Since the unit is the metric ton, which is 1,000. So you just multiply 1,000 on whatever given. So it says 500,000. So this is the one that we look for. So if you draw a line like here, it's going to be 1982. So that's why it is, oh, there's no answer choice, it's 1982. Then you have to straight down more. Oh, you see around 1990, 1987. So 1987 will be the answer. Oh, move on to next passage. Same thing, we're straight to the question. It says, based on the result of study 2, did male rats or did female rats consume more caffeinated cola per day? So let's go to study 2, and then the result that you see, which is figure 2. Key is caffeinated cola is dark one, and then drink water is lighter one. And then group 1 is male, that, you know, Y value, if you read, it says total fluid consumption per rat. And then the male is drinking about, I'll say 55, and then female is around 75. So then that's group 1 and 2, right? So then if you compare that, the female rat's drinking more, so which is G. And number 7, which 2 groups of rats serve as a control group? The control group means something that we limit for their activities and whatever, in this case, the consumption, so that, you know, we can compare to the, you know, the whatever group that we're doing experiments with. So since it says study 2, so we have to find something that, you know, some clue from, because from the figure 2 and 3, we can't find much about this. So we have to find something that, you know, from the whatever clue from this. And also maybe like, you know, even like from figure 2, the graph itself, I mean, we can understand that, you know, group 1, 2, you know, cola and drinking water, both of them they're drinking. But then, you know, group 3 and 4 is just drinking water. So maybe like 3 and 4 is control group, because they're comparing to the group 1 and 2 that, you know, if they start drinking caffeinated cola, how their, like, you know, water consumption is going to be different. So yeah, maybe that's like, you know, D. And also passage that it talks about that too, like, you know, how they limit the caffeinated the cola. Number 8, in study 2, the average daily total fluid consumption per rat for group 4 was approximately half of that of average the group 2. So 2 and 4, we're comparing which following statement give most likely the reason. So if you think about from the figure 2, this one, 4 and 2. So then 4 is half of the whatever, you know, the 2. But then, you know, as you see, they drink more caffeinated cola. So you probably have experience of drinking cola. That means, I mean, you probably know that, you know, it's sweeter and probably like, you know, nice to drink a lot more, because it's more like, you know, I mean, like, you know, water itself is for the just like, you know, for thirstiness. I mean, like we quench our thirst, we try to like drink, but then for the cola, it's more about, you know, your preference, like, because it's sweet. So it's a higher because they drink cola more than water itself. That's why it's a H. So a lot of times you can use common sense on the science section, because most of the time it makes sense. And then number 9, study 1, greatest number of women were assigned to the group that consumed how many servings of caffeinated cola per week. So it says study 1, so you go study 1, but then it says whatever the figure 1 that you see is figure 1, that x-axis caffeinated cola consumption per serving, a serving per week. You see that, you know, whatever graph that, you know, average BMD, but then it doesn't really talk about specifically how, you know, greatest number of women were assigned. So we don't know. So when you read answer choice, if you have something like cannot be determined, then back of your mind is supposed to have sort of like an idea that it might be the answer. So that don't just like trap to the irony that you have to find the right answer all the time. Then you just waste your time for that. Number 10, BMDs of subjects study 1 and 2 were determined by scan of their hip bones. Based on the figure 1 and 3 was average BMD for any group of rats greater than or less than average BMD for any group of women. So first of all, we don't know what BMD, right? This is a case that you have to go up to the beginning of the passage and you have to understand, what it is. So it says bone mineral density is the BMD. And then if you read next line, it says low BMD increases the risk for bone fracture. So you have to have like a higher BMD. Then if you see the study 1, figure 1, that you don't drink cola, that means your BMD is higher. And then if you drink a lot of cola, then it's lower. And then same thing with figure 3, if you go, it says average BMD on the y-axis, the male, female, and then the whatever. And then group 4 is the one that, only drink water, but then amount of water drinking from the figure 2 is greatest. So that it kind of like, relate to not drinking cola and then drinking more water will be like better. So then now coming back to the question, says that the was average BMD for any group of rats greater than any or less than average BMD for any group of women. So here we don't see much, but then I guess rat is the case that, I mean, hold on a second. We don't know women and rats. Okay. Oh, okay. So study 1, if you read study 1, the very first sentence, it says adult women. So study 1 is about women. And study 2 and 3 is rat. So then if you think about the BMD, the absolute value of BMD self, which is not drinking the cola, the BMD is 0.89. But then the female, like the group from figure 3, then BMD is only like 0.15. So the women is greater. So which means rat is less, rat is less. So because of that, it is H. And 11, consider the statement. It is possible that average BMD differ among the groups in the study partly because the subjects in the study are different types of solid food. The statement applies. So different solid food is study 2. It's just like specifically talks about, if you go study 2, the description 1, 2, 3, 4, this lines provide with unlimited supply of solid rat food, right? And then like later part 2, unlimited supply of rat food. So that's controlled for study 2. For study 1, it says it didn't say much about whatever food they're eating. So that's like uncontrolled. That's why I study 1 only. So it's A. Move on to next one. So page the question number 12. It says over 30 hours of experiment, temperature of water in the bottom tank X. So tank X, if you think about it, this one, right? That's how it looks like. And then tank X key, which is figure 2, is tank X. And then if you see the bottom is the reverse triangle, like so which means bottom is going like slowly, like slower down, and then it decreases. But then compared to I mean later part, from once it hits 0, it just stays same as a 0. That's why it's J. And 13, compared to the water of the top of tank Y, so which is figure 3 if you look, and then the bottom of tank Y, approximately how many more hours or how many fewer hours reach 0 degree. So which means this point and this point, that, this point. So this is a bottom, right? It takes 24 hours. And then this one takes only what? Like around 10 hours? Like, yeah, around 10 hours. So if 24 minus 10, it's like 14 hours. The closest one is 15 hours. So C is the answer for this one. Moving on, number 14, two streams, stream A, stream B, are identical in all respects, except the water flow rapidly stream A, but then nearly at rest in stream B. Based on the result of experiment during the prolonged period of -5 degrees Celsius weather, the water at the top of stream less likely begin freeze first, or why? Obviously, this is the case that you have to think about the the common sense. Like stream A is the one that having rapid stream, goes faster, and stream B is slowly. So which means it moves faster and it has less chance to freeze because the bottom one is warmer, so it's coming up, heating it up. So because of that, it has to be F, because stream A, because it indicates that freeze slowly because it moves like more. And then 15, suppose the tank Y covered throughout this experiment, and then how it's going to be. So like top is the part that it is exposed to the weather, so it freezes top first, but then they cover it up, then the entire thing is going to be like affected by the weather outside. So now like top and bottom, the difference is not as great as whatever that we see from. So tank Y, we see from the figure 3, if you go tank Y, and then it says at 2 hours. So you draw a line at 2 hours here. So then the gap, the range is 8 to, like, I'll say 11, 8 to 10. So that's why it has to be safe enough to say 8 to 14. And then number 16, suppose that both tank left the freezer until the CO2 each reach the thermal equilibrium and air in the freezer. Based on the passage temperature, H2O tank mostly like have been. So then you have to find the whatever situation. Then this is something that we have to figure out from the passage, because we don't know the temperature of the freezer. So if you skim through in the beginning part here, then you can find, oh, it says temperature control freezer set to -12. So then at the end, it's going to be -12, because that's what the how low it can go. Move on to next one. This passage is what we call contrasting viewpoint. Usually I'll say, when you do contrasting viewpoint, do it at the end, because it takes longer time. And also when you do the one like this, you have to read through one by one, and then you have to find the difference among scientists 1, 2, 3, 4. But then since it takes longer time, you probably get frustrated, because if you think about later on, oh, what if I cannot finish the test? So just push this one at the end, so that you just do everything else faster, so that you have more time, and then at ease you can do this one. But for me, I'm just going to do it because for the sake of explaining everything. So move on to the passage itself. Without reading the answers, I'm going to read the passage itself. But then how you're supposed to read passages, you have to have a specific purpose to read passage. So you have to skim through it, but at the same time, you have to know what's going on. So it says, for 1800s, scientists provide different gas models that attempt to explain what happened when gas is released into evacuated container. So that's the important part here. And what happened to gas in closed container? A fixed volume is heated. So basically that's what happened, right? Scientist 1 says gas is composed of small particle that repel each other. Particle are bound together but never in contact with each other. If gas is released into the evacuated container, the particles in the lattice will move apart from each other until the gas completely filled in the container, then stop moving. Thus, the particles can move only if the size of the container changes. So that's like the given like in the first the scientist idea. Oh, there's one more paragraph, and then if the gas is close to the container, fix the volume. So that's another one. Fix the volume. To hit it, the repulsive force between particles will increase. So which means they're pushing out each other, right? And then that's why it cannot change distance between particle because it's only like limited volume, but does cause the lattice to push harder against the container and does increase the pressure. And then second scientist model correct. Only exception is gas closely contained the fixed volume is heated, the repulsive between force will decrease. Okay, so it's like opposite to increase and then decrease. So that's like the difference. And then 3, so this is only fixed volume, right? And 3, gases composed of particle repel each other. The particles are not bound to each other. And then if the gas released into evacuated container, the random motion will cause. And the gas particle on path to collide, repulsive force between particles will push each other, and new path. Those gas particles never collide. And then gas enclosed the container of fixed volume, heated, the speed of the particle will increase, and then finally the pressure to increase, and then temperature no effect. Increasing temperature has no effect on the repulsive force, so temperature increased too. And scientist 4, everything is same with the scientist 3, but then it says collide with each other. When they do collide, elastic because no energy is lost during the collision, so it doesn't like hitting each other. So like, you know, just roughly reading through this one, and then number 17, it says claim that gas particles are attracted each other. Attracted, it didn't say anything about attracted. It's just like, you know, pushing each other or colliding each other and things like that is whatever they talked about. So it's the, and then 18, which scientist would most likely be predict that hitting the air inside sealed volume will cause the volume decrease inside. So pressure is decrease is the one that we can see, which is from here, scientist 2 at the end. It says gas lattice is pushed down against the, so it says particles will decrease, yeah. And then gas particle 1 and 2 are moving straight toward each other and then induced by the dotted arrow. Okay, so this one. And then based on scientist 3 model, which is following the diagram. This is like in a fixed container, because it is like, you know, one, the red rectangle that we can see. Then what happened is, it says random motion will cause, and then they're like sliding out each other, right? So never collide each other. That's why it is A or B. But then sliding, and after that, what's going to happen is it's moving to same direction or different direction. It says new path in the passage. That's why it is B. We'll move on to next question, number 20. It says consider the graph shown below pressure versus temperature for a gas in the closed container of fixed volume. So temperature goes up, and then temperature, the pressure goes up. So the first one, yes, because it says pressure increase, and then second one, it says decrease, so it doesn't work. And then number 3 and 4, both of them says that, you know, the pressure goes up. That's why it is H. Same thing, you know, you have to use common sense in a way for this one too. And then 21, it says tank A contains 5 grams of helium, and then B contains 10 grams of helium, and then temperature gas each other. 25 Celsius, and then tank the same volume, what the scientists for most likely predict that pressure would be greater tank A or tank B. So since it says that, scientists for, if you go, it says, third line, does gas particles can collide with each other? When they do collide, the collision are elastic because no energy is lost during the collision. So, which is, if it's fixed container, then, they're not colliding each other. Then, since it's not colliding, the pressure gonna, it's moving around, the pressure gonna build up more. So that's why if you have more, the helium inside of same container, then it builds up more pressure. That's why tank B has to be, because it's not, it's just pushing each other. I mean, pushing the wall itself, because it doesn't collide. That's why it's C. And 22, which of the scientists would agree with the statement, if a gas is kept in a constant volume and temperature, the gas molecule will have no motion? So constant volume. The volume is stays same, then which one is talking that it doesn't really giving any difference in the change of the pressure is temperature and pressure is the first two, because the scientist one, it talks about the particles are bound together, right? Scientist one says, the second line, it says particles are bound together. So which means it just stays there, but something happened, which is gas release into evacuated container. That's the time that they move apart, but otherwise it stays same. And then scientist two says same thing. It says scientist one model is correct with only one exception. So everything is same. Because of that, the answer is G. And then 23, it says scientist textbook described the gas according to a model called kinetic theory of gases. The kinetic theory of gases is most consistent with which one? Kinetic energy of this one is kinetic energy means moving, right? So it talks about how they're moving around, but then scientist 4, it says elastic because no energy is lost. So which means we keep the same energy. That's the basic idea of what kinetic theory of gases. So which is D. Moving on to next passage, two more passage we have. So again, we're going back to the original way to do, which is question number 24, according to the result of study 1. So then we only need to pay attention to study 1 for the initial BR concentration of 200 or 500 as contract time increase, BrO3 concentration increase or decrease. So study 1, if you go, which is figure 1, if you go, it says contact time is, it says initial BR contained the 200 or 500. In the initial one, I mean, if you think about the 200 and 500 here, circle or the square. So initial circle square, it increases as time goes by, rapidly for 500, and a little bit slower in 200. So that's why we can find it as increase only. Both of them increase. And 25, suppose that scientist 1, a 1 liter water sample having an initial BR minus concentration of 350, and the sample pH as the other 3 samples had also been tested at the contact time 15 minutes, and the BrO3 concentration for the sample would most likely have been. So study 1, you go, and then 15 minutes, and then it says also 350. So we don't know 350, but then between these two, so it has to be between these two, right? And the concentration has to be somewhat around like 20 and 50. So going back to the question, we can find it from C. And then 27, it says, according to the result of study 3, the contact time after 0 minute, how did addition of ammonia to the water sample affect the production BrO3? So study 3, ammonia added is this one, and then no added is the triangle, empty triangle. So if you're putting ammonia, it actually lower, right? The concentration. So going back to the question, it says at the 0, it's all same, right? As time goes by, it is actually like lower. So which means A. And then 28, it says what variable had the same value for all the water samples, study 1, but did not have the same value for all the water sample in study 2. So study 1 and study 2, we're comparing this two. And then, so if you, in this case, you have to read through a little bit, and then anything that you can find from study 1, read through, nothing really like, different you can see. But then study 2, as soon as you read study 3, third line, it says having a different pH. Oh, bingo, right there. So pH is J. And also from the figure 2, if you compare figure 1 and 2, that's another way you can figure out too. If you look at the key, Br concentrate is whatever for the figure 1, but then figure 2 is more about pH. That's another way you can put it too. And 29, based on the result of study 2, was more BrO produced during the ozonation of the acidic water sample or basic water sample. So if you look at the study 2, which is Y value is BrO concentration, and then the whatever acidic. But then, we need to understand what is ozonation. But then, since we don't know much about it, then we have to read through like in the beginning of the passage. And then it says ozonation is right here in third line, which it says when BR present O3 and then BR produce bromide ion BrO3 in drinking water BrO3 concentration, this, whatever, unsafe. So if BrO3 is higher, then it's not safe. And then coming back to the question, it says acidic water sample or basic water sample that we see BrO3 more. So higher BrO3, which is the circle one, right? So 8.4 is the higher. So 8.4, the lower number is more acidic and the higher number is more basic. So it has to be basic. And basic because the higher concentration, so it's D. The last passage, the one second to the last passage, I think. Yeah, second to the last passage. Question number 30, it says based on figure 1 for the star cluster that is 5.0 times 10 to the 9 years old, BM minus BB, MB minus MV will be closest to which of the following? So you go to figure 1, and then MB minus MV is x-axis. And then the question says 5.10 to the 9. 5, 10 to the 9, 10 to the 9 is here. So you draw a line like this, which is around this area. So 0.6, so it's J. And then consider a star cluster having a particular star for which V equals MV, based on figure 2, which is on our left side here, figure 2, distance from the Earth to the particular star will be which of the following? So V equals MV, which is, it becomes 0, right? But then the whatever part that, 0 that you see is the PC, which is here, PC. PC is 10, the Y value is 10, that's why it's B. And then based on table 1 and 2, the power outlet visible light greatest from the particular stars in which 4-star cluster. So greatest power outlet is greatest when you see that MB is lowest. That's the greatest. So then if you go table 1, when since MB is lowest, MB is lowest is this one. So cluster 2 is the lowest. That's why it is G. And based on table 1, MB for the particular stars in SC1 is which of the following? So table 1, MB, it says the SC1 is the one that, whatever they're looking for. So this one. And then what we see here is the MB is not given, but then only something that relates to MB is like this one, the last one. And it says the first one is 0.00. Now we have to understand, something that we can relate to MB at the SC1, then you can find the value of that as well, because that's what we can compare it to. So then where can you find the cluster 1? The MB is, if you see MB is this one here, 1.5, right? So then MB has to be 1.5 as well. So that's why it's C. And then 34, it says MB minus MB increases stellar surface temperature decreases. So based on table 1, the surface temperature lower for the particular stars in SC3 or for the particular stars SB4. So it says that MB minus MV increases. So you look at the MB minus MV, the increase is 3 and 4, both of them are increases. But then which one is greater is 4. That's why the answer has to be J. Move on to the last one. So same thing, we don't look at the question, we just look at the, we don't look at the passage, we look at the question. It says, if study 1 trial had been conducted in which V equals 9,000 and R equals likely being closest to which one? So study 1, we have to go up somewhere, study 1. So V and R is given from table 1 and says, it says V is 9,000, so it has to be greater than this one, 1.4. So then going back to this one, so greater than 1.4, 0.14 is B. So 36, suppose the new trial, a student repeated the procedure used in trial 6. Iron source malfunctioned. The student detect ions at 2 values of R of these 2, which are the following statements regarding the electrical charges of ions in this new trial best explain the result. So if you go, something that we have to find is iron and then like Q value, and then like also it gives you trial 6, and then trial 6 is only we can find it from here. Okay, so Q is +3, and then R is 0.047. And then, so if you think about here, going back to the question, it says 2 values, R is 0.047, and then the Q is, and then whatever. And then the given, like in a table that, whatever we see, Q was 3, right? So it has to be between H and J. And then the remainder of the iron is Q is +2. Then you have to look at the +2, which is 0.70, like this one. So because of that, it has to be H. And 37 says that they are also accelerating travel metal plates in the detector, and the interval of motion where iron's acceleration because magnitude of their velocity is changing, or because of direction of the velocity changing. Okay, so then we have to find the iron source to hold. Iron source is this one, like on the figure one, and the detector is this one, and the hole is this one. So iron source to hole is, if you shoot out faster, it's going to go far away, right? So which means how fast it can go out is important. That's why it has to be, velocity is important, magnitude itself, right? So and from hole to detector, so the direction, this way it goes or that way it goes. So the direction is important. That's why it's B. And then number 38, based on the result of 3 students, R is directly proportional. Directly proportional means as R increases, and then like something else increases as well. And then inversely proportional opposite. R increases, something else decreases. So if you look at the each one of them, table 1, R increases, V increase. So V is directly. So it has to be between F and H then. So we can just test it out, Q first. So which is, we can find it from, table 2. As you see, R decrease, Q is increase. That means it is inversely proportional. That's why it is F. And 39, suppose the procedure used the trial 7 repeated in the new trial, except the B equaled 0.12, and instead of this, the result of study 2 and 3 are most likely have been. So trial 7, if you go trial 7, which is here, like Q is +4, and then R is 0.335. But then it says that B is now different. So it says B is equal to 1.0. So now we can find the B and R, the relationship between B and R, which is table 3. If you go, B is increase, R is decreasing. So which means B increases from like 1.0 to, what is saying in the question, 1.12. Then means R has to be decreased, which means A. 40, the last question. Based on figure 1, the distance each iron traveled along its path from the time it left the hole, the metal plate, until time coming all the way to there. So then if you look at the shape of this one, this is half circle, right? This is half circle, but then radius is R. So then 2 pi R is circumference, entire circumference, but then half of it, so pi R is the answer. So which is H. So this is it for the science section. I hope this helps. And also, I want you to think about how I approach to the questions. And then what I try to do was, I only look at the important information. And also, as I finish this test, I have no idea what's going on at all. So without reading the passage, it's still fine. Please, utilize the way that how I teach you today. And then, I hope that you can get everything right. So we'll see you next time. Bye-bye.